Welcome back to Eat Study India. Now we will study about the language accepted or recognized by deterministic finite automata. Suppose there is an automata M, okay, and LM is the language which is being accepted by the M. So language which is accepted by the M, it is denoted by LM, which is equal to, for instance, W. W is the string or a word which is accepted by M. So M accepts W. So W is a word and it belongs to epsilon star. Epsilon star means it is the uh, universal set of all types of strings which can be built by the given symbols in the epsilon. For example, if epsilon is equals to ABC, then with the combination of ABC there is the infinite number of strings which can be formed, right? So this is a universal set of the all the strings which can be formed using the symbols in the epsilon. This we have already discussed in the previous lectures. For example, if we talk about M is the string which is accepted or the language which is accepted by DFAM. Now, Q is the set of states which is Q0, Q1. Let Q0 is the start state, and epsilon is a set of strings or symbols, and delta is the set of transition functions. Q0 is the start state, and F is the final state. So, final state is Q1, right? It is written here. Now, transition function is given delta Q0 if the current state is Q0 and input symbol is received as 0, then the next state will be Q0. That means if there is a state Q0 and you have received an input symbol as 0, then it will come to itself, it will call itself and as a Q0. Then if the transition function is 1, sorry, current state is 1, Q1, and the input symbol is 0, then it will call itself, right? But if the transition function is Q0 and its input symbol is 1, then it will call Q1, that is another state. And if the delta transition function is current state is Q1 and it will call 1, it will call itself, that is Q1 itself, and it will be the final state. Now it is a formal description of DFA, but it is hard to comprehend. Now let us see its transition function diagram. Now this is a state transition diagram. Q0 is the initial state and Q1 is the final state. Now in initial state, if we give it the input as 0, then it will come to itself, and if in Q1 it is given as 0, it will come to itself. Even if it is given 1, it will come to itself. Now in Q0, if it is given 1, it will go to Q1. Now this is called the state transition diagram, which we can create from these set of transition functions. Now someone has just asked me what is the transition function, please explain. For that I think you might have understood it by till now. Now next, if we make the transition table, for transition table what happens is Q0 and Q1, and if input is given as 0 and 1, for Q0, if the Q0, this means a start symbol and this means a final state. So for Q0, if the input is given as 0, then it will be Q0. With these kind of functions, we can create easily this transition diagram. And to comprehend this transition diagram, what we do is we are giving the start function to Q0 and then final Q1, and then for Q0 for 0, Q0 for 0 will give this. And now what happens in this state transition diagrams is that, just check, if there are two states and there are two symbols, so we have 2 by 2, that is 4 transition functions for this. Okay, if we have 4 transition function for this, then it means we have deterministic finite automata. It means it is complete in itself. For any state, if we are choosing any symbol or if we are choosing any input, then we will be able to determine the output. Now suppose we are getting 0 0 0 1, right? And we will go to the start state and we'll find 0, it will go to Q0, and then 0, then 0, then we will get giving 1. Then it will go to the final state and it will accept it. If we will give 0 1 0 0, then it will go to 0, then 1, then 0, and then 0, and then it will accept it. All those strings will be accepted by Q1 except if it is only 0 0 0 0 0 0 or any form of 0, that is 0 raised to power n. So any form of this language can be accepted by Q1 if it contains at least one 1. Now if we talk about the tabular representation of the transition function in the transition table, then the rows are the states and columns are the input symbols. Now entries are corresponding to the next state. Like for Q naught, for input 0, what will be the next state? The start state is always marked with an arrow and the final state is marked with the star. Now if in the in the state transition diagram, what happens is that the final state is marked with a double circle, and rest of the all the states are marked with a single circle. And if for any state, if for any input symbol, if it does not go to the final state in the end, then the string will be rejected. As I've already told you that 0000 will be rejected, 0 raised to power n, and for n greater than 0, any greater than or equal to 0, any symbol will be rejected. It should have at least one 1. 0 1 0 0 0 0 0 will be accepted. Any kind of 0 or 1 combination will be accepted by this string in the final state. Now in the next we will find out how to remove the transitions and what are non-finite automata, and so on. Please like the video if you like it, dislike the video if you dislike it, and comment in the comment section below whatever problems or doubts you have. If you want, we can also start with the practice sessions, but please do respond so that we can get motivation to create new videos and more videos. Thank you.